welcome to all of you in this second lecture on materials management. In the first lecture on materials management, we started the discussion with a very simple example of buying the potatoes. If you remember, we have seen that what are the different decisions that we have to take when we go out to the market to buy any simple commodity such as potatoes. We have seen that materials management is one of the most important aspects of industrial management or industrial engineering. We have seen that what is the scope of materials management, what is the responsibility of the materials management department, and then we have seen that inventory, that is the stock of materials kept in order to meet the future demand, is a very important part of materials management process inside the industry. So we have seen that inventory is required, it is essential, and what are the needs of holding an inventory and what are the advantages that we derive if we maintain a certain amount of stock in our inventory. So we have seen that inventory is an essential part and it has to be operated upon, or it has to be kept, or the stock of materials has to be held inside the industry in order to avoid certain breakdowns, or in order to avoid a smooth flow, breakage in the smooth flow of the manufacturing processes. So we have seen so many advantages can be derived if we keep a stock of materials, but it is not that easy. Whenever we keep a stock of materials, there is always a cost associated with that. Suppose let me take an example of a warehouse which is keeping the inventory of refrigerators as well as the television sets. So if we are managing an inventory of 100 refrigerators and 100 television sets, so we can see that what will be the floor area required to manage this type of a warehouse. And if we put a cost on each square feet of the floor area, it will run into thousands of rupees if we are managing this warehouse in a very busy market. So holding an inventory is also very important, and it is associated with economics. So money is required to hold an inventory. We can call it as a carrying cost or the holding cost. Similarly, when we are ordering, we have to do a complete process. That's why we have covered in the last lecture the procurement process. It has different steps, and at each and every step there is money involved or the economy involved in the procurement process. Placing an order, doing a comparative study, so many things are there that we will cover, that what comprises of a ordering cost. So there is a ordering cost associated with holding an inventory, there is a carrying cost associated with holding an inventory, and all these add up to the total cost of the inventory. So in today's lecture we will start our discussion with the different types of costs associated with the inventory, and then we will try to find out another important point, that is what is the optimal quantity that we should order. Then there are different models for this. There is a economic order quantity model, there is a production quantity model. So we will see that what are these models, what are the assumptions of these models, and then we will try to solve certain simple problems so that you get an idea that what are these tools and how these tools can be used in order to solve problems related to inventory management in specific and materials management in general. So we will start today's discussion with a brief introduction to the different types of costs associated with the inventory. So in the next slide I am just going to show you a very simple diagram. On your screen you can see that on y-axis we have the costs, and on x-axis we have the quantity or the order size. So we see that as the order size is increasing, now this is the ordering cost. The color of the text also explains. This is the blue color, and the blue color line is showing the ordering cost, and similarly this is the red color. If we call it as a red color, this is the holding cost. So we can see that as and when the order size is increasing in positive x direction, so as the order size is increasing, the ordering costs are decreasing. So we can say this we have already covered in the last class, that if the quantity will be more, the ordering cost will be less. Similarly, the holding cost, already I have told you, with the help of an example I have told you that holding cost basically is associated with holding an inventory inside the workspace or inside the industry. So it will require certain space. It may also require certain air conditioning requirements, certain environmental requirements, certain humidifying requirements. So certain requirements are there and those will add to the cost. So whenever we are holding an inventory, it will be having some cost, and the holding cost will also be increasing with the order size. So when the order size is increasing, the holding cost will increase, and when the order size is increasing, the ordering cost will decrease. So the ordering cost is decreasing and the holding cost is increasing with the order size. So we find out the total cost. Now total cost of holding the inventory will be a summation of the ordering cost and the holding cost. So we have already seen, just to summarize, as the order size increases, the ordering cost decreases. As the order size increases, the holding cost increases, and then the total cost is found out by the addition of these two, and the green line is showing the total cost. Now total cost is this much, this may be rupees Y, and corresponding to the total cost there is a minima that is happening at this point, and this is called as the economic order quantity. So this economic order quantity we need to find out, at which the total cost is giving us the minimum value. So after adding the holding and the carrying cost, or ordering and the holding cost, sorry, I have said holding and the carrying cost, that is one and the same thing. So holding cost plus ordering cost, when we add, we get the total cost, and wherever the total cost is minimum, that is called the economic ordering quantity. Now there may be, I have been using these words quite often in this lecture itself: ordering cost, holding cost, total cost. So we need to understand that what comprises the ordering cost, what comprises the holding cost, that we are going to discuss in the subsequent slides, so that you may be able to better have an idea that what is the ordering cost and what is the holding cost. So the inventory costs basically are carrying cost, which can also be called as the holding cost. This is the cost of holding an inventory or holding an item in an inventory. So the carrying cost can be said to be per unit. So per unit carrying cost is this much. It can be $0.75 per unit. It can be $1.5 per unit. So the carrying cost is the cost of holding an item in the inventory. Ordering cost basically is cost of replenishing the inventory. Now the inventory has declined, or the stock of items that have been kept in the inventory has declined to a particular level. Now we want to replenish it, we want to reorder, we want to again have the stock to a particular level. So that basically is the ordering cost, or the cost associated with replenishing the inventory is called the ordering cost. We will also see that what are the various components of cost that will add up to make these costs in the subsequent slides. But right now, just in order to understand the various terms that are used in finding out the economic order quantity, that we are trying to discuss. In the first diagram I have shown that the ordering cost decreases with the order size and the holding cost increases with the order size, and the total cost minima gives us the economic order quantity. Then there is a shortage cost, that is a temporary or permanent loss of sales when demand cannot be met. So always there is a cost associated with the shortage. If the material is not available with us, we will not be able to have a smooth flow of products or the smooth manufacturing of the products because of this shortage. So there will be a cost associated with the shortage. Now different types of cost, we will try to have an idea that what are the various components of the ordering cost, what are the various components of the carrying cost, and we will see that how these components add up to make up a total carrying cost and a ordering cost. So let us see that what is first the unit cost. It is usually the purchase price of the item under consideration. If unit cost is related with the purchase quantity, it is called as a discount price. So unit cost is basically the money that we spend in order to acquire that item or in order to purchase that item. But if certain discounts are available, then we call it as the discount price. So we can see that unit cost is something that is related to the cost of the product or the price of the product or the purchase price of the item under consideration. So here in our discussion we will take the unit price as the purchase price of the item under consideration. Then the ordering cost. This includes the cost of the order preparation, tender placement, cost of postages, telephone costs, receiving costs, setup cost. So all these costs will add up to finally form the ordering costs. So you can see that there are so many components of the ordering cost. So if the quantity of the order size will increase, this ordering costs will decrease, which has been shown in the very first diagram with which we started the lecture. So once again, to give you an idea that what are the various components of the ordering cost, I will read it for you. This is the tender placement cost, cost of postages, telephone cost, receiving cost and setup cost. So all these costs will add up to form the ordering cost. Now next is the carrying cost, the cost of maintaining the inventories in the plant. Now we have ordered, we have received, and we are now keeping a stock of those items within the plant or in the industry or on the shop floor or in the storehouse. So the cost associated with maintaining that inventories in the plant is called the carrying cost. So it includes the cost of insurance, security, warehouse rent, taxes, interest on capital engaged, spoilage, breakage, etc. So we can see there are so many components that add up to the total carrying cost. So we can see that if we depute 2 security men outside the store, that is going to add to the carrying cost. If we want that whatever material we have put in the inventory that requires a refrigerated atmosphere or certain temperature has to be maintained, then that the cost of running that kind of equipment will be added up to the carrying cost. One example already I have given, that if we have to manage an inventory of refrigerators as well as the television sets, again the floor space requirements will also add up to the carrying cost, or the rent that we have to pay in order to manage that warehouse will add up to the carrying cost. So just to revise that what are the different types of carrying cost, that is it includes the cost of insurance for sure, security, warehouse rent, taxes, interest on capital engaged. Now this is an important point, that we want that minimum amount of capital should be tied up to the inventory, and that's why we want to find out the economic order quantity, so that less amount of capital, that is the total cost involved in the inventory, should be minimum. So interest on capital engaged, because all the industries will have certain capital and they might be paying certain interest as they might have arranged the capital on loan. So that interest will also get added to the carrying cost. And the spoilage, breakage, this is very simple, that even if certain amount of items are spoiled or are broken down while transferring them within the storeroom or in the warehouse, that will also be added to the carrying cost. So we have till now seen that what is the unit price, what is the ordering cost, what are the different components of the ordering cost, what is the carrying cost, what are the different components of the carrying cost. Now last is the stock out cost, that we have already seen as the shortage cost, the cost of loss of demand due to shortage in supplies. Now for example, there is a demand in the market, but because of shortage of the raw materials available in our inventory, we are not able to supply that the final product for which the demand is there, or we are not able to service that demand which has been raised by the customer. So this is going to result in a loss. So this includes cost of loss of profit. If we would have been able to meet that demand, we would have got certain profit, but as we are not able to meet that demand, then the loss of profit is going to take place. Loss of customer, then the customer will automatically go to some other competitor. As I have told you that if a customer comes to the showroom and he wants to buy a motorcycle of our company, but we are not able to meet that demand because of the lack of materials or lack of inventory in our manufacturing plant. Then the customer will automatically switch to some other competitor. That's why we are losing the customer, we are losing the profit, we are losing the goodwill, as well as sometimes we may even have to pay the penalty. For example, we are manufacturing a particular product for a particular company, and we have agreed in our contract that we will be able to supply this product after 3 months, and after 3 months every alternate week will invite a penalty. Now because of the lack of materials that are available in our inventory, we are not able to meet that stipulated time of 3 months. So every week now we are paying a penalty because of the lack of materials or the stock out cost. So this cost will be added to the stock out cost. So if we are not able to manufacture the material on time, or there is a stock out situation. What is a stock out? One line definition I will give in the subsequent slide. So if there is a stock out, then there are so many costs associated with it. So what are those costs? Loss of profit, loss of customer, loss of goodwill, as well as certain penalty costs that are there in the contract agreement between the supplier as well as the buyer. Now inventory control systems. There are two types of inventory control systems. Namely continuous system. In continuous system we are having fixed order quantity. What does this mean? This means that constant amount ordered when inventory declines to a predetermined level. Suppose we have 100 parts in our store. Every day we are using 10 parts. So after 8 days, 10 multiplied by 8, because 10 parts we are using per day, 80 parts will be used, only 20 will be left. Now we will order again 100 parts. That is fixed order quantity, constant amount ordered when inventory declines to a predetermined level. Now what is this predetermined level? Predetermined level is 20 in our case. We already have 100. Every day we are using 10. After 8 days 80 have been used, 20 are left. So this predetermined level is 20. As soon as 20 are left, we are again going to place an order. So that order will be fixed order quantity order. That may be 100, that may be 500, that may be 5000. But the amount or the predetermined level is fixed. So this is called as the continuous system. As and when we are using the inventory, as soon as we achieve that level or we reach to that level where we have to again place an order for the fixed order. Constant amount is ordered when the inventory declines to a predetermined level. Now contrary to this, there is another control system which is called as the periodic system. In periodic system there is a fixed time approach. In first case there was fixed order quantity, means the quantity is fixed. In this case time is fixed. So order placed for variable amount after fixed passage of time. So the amount is variable here, but the time is fixed. Now we can say this periodic system, it can be very easily understood if we take an example of a shopkeeper. A shopkeeper is running his business. Suppose he is selling the cosmetic items. A particular salesman of a particular brand comes to this particular shopkeeper after every 1 month. So the time is fixed, 1 month is fixed. Every 1 month the salesman will come and this particular shopkeeper has to order whatever quantity he decides. Suppose he has face creams, he has ordered last time 100 face creams. Over 1 month he has been able to sell 40. So 60 are already lying on his shop. So he can take a decision how much he should place an order after 1 month. But the time is fixed. Every 1 month he has to place an order. In first case the quantity is fixed. As soon as the quantity comes to that level, no matter what is the time, the order has to be placed for the fixed quantity. But in this case the quantity is not fixed, quantity is variable. We have, as you are on your screen you can see, order placed for variable amount or variable quantity after fixed passage of time. So the time is fixed, that after every 1 month or after every 15 days or after every 7 days you have to place an order of the variable amount. So we have to take a decision as a manufacturer or as a materials management personnel that what type of system we have to follow, whether it has to be a continuous system or it has to be a periodic system, because this is also going to have a bearing on the total cost of holding an inventory. Now we come on to a very important tool which is used in inventory management, which is called as the ABC classification. Now, having taken a decision that we are going to hold an inventory, there will always be a cost associated with holding an inventory, that we have already seen. There will be a total cost. Wherever the total cost will be minimum, that will be the economic order quantity. And then in the last slide we have seen that there are two types of systems. One is the periodic system, and another one is the continuous system. All that we have already covered. So we have to now see that how the materials will be classified. So ABC classification is one of the most important classification schemes used in order to classify the materials into three categories. So here we see that this is a classification that is based on either the cost and the volume. So either we can, on the basis of cost only, we can say this is the classification of materials that are used in our industry, or on the basis of volume, or on the basis of both. So the criteria on the basis of which we are going to classify these items is given on your screen. So we can say that class A items will be the items which will be 5 to 15% of the units. So on the basis of volume, these will be 5 to 15% of the units only. But from the point of view of the value, this will be 70 to 80% of the value. So we can see class C items are those items which are less in quantity, but the dollar value associated with them or the rupee value associated with them will be 70 to 80%. So these are costly items. So the costly items which have more value are having less number of quantity, or they should be stored in less number of quantity. Similarly, class B items are items which will be 30% of the unit. So 30% of the total volume, but 15% of the total value. Similarly, class C items will be 50 to 60% of the units. So this is bulk. Suppose we take an example of any manufacturing company. So the stationery items, pen, pencil, copies, all these things can fall in the class C items. So we can hold a large inventory, or the amount of these items can be more. So 50 to 60% of the units by volume will fall under class C, and 5 to 10% of the value. So the money associated, or the dollar value associated, or the rupee value associated with class C items is less. It is 5 to 10% only, but 50 to 60% of the items. So the volume wise it is more, but money wise it is less. So this we will try to understand with the help of a very simple diagram. Now on your screen you can see a diagram which clearly illustrates that on y-axis this is the percentage of dollar value, and on x-axis this is the percentage of inventory items. So once again, just to repeat, percentage of dollar value is on the y-axis and the percentage of inventory items is on the x-axis. So we can see that A class items or A items, these are having 80% of the dollar value. This is the percentage of dollar value, 80% of the dollar value, and only 10% of the inventory items. So only 10% of the inventory items which are having 80% of the dollar value or the total value, these will be classified as A class items. Similarly, if we come to B items, B class items are having 10, 20, 30, maybe 30% of the total volume of items or total volume of inventory items, and the cost associated or the dollar value associated with this is maybe 15%. So the dollar value is less and the percentage of inventory items is more. Similarly, the C items, we can see that the percentage of inventory items falling in C category items is much more, but on the other hand we can see that the percentage of dollar value associated with these items is decreasing. So this can be said as 5% only. So the percentage of dollar value is only 5% associated with C class items, but the amount of items or the volume of items we can say is much more. We can say this is from 40 to 60, maybe 60% of the item, sorry, 40 to 100, we can say 60% of the items are falling under the C class item. So how this classification is going to be helpful? Now in an industry, so many type of materials are being used. Some are very costly, some are relatively cheaper, some are very cheaper. So we have to classify, so that in order to optimize the total cost that is tied up with holding an inventory, if we keep equal number of items of each and every class of items, then the total cost involved in holding that kind of an inventory will be relatively higher. But if we segregate the total number of items into different categories, as here we have done, we have classified into three different categories: class A items, class B items, and class C items. So overall we are able to optimize the total cost that we are spending, or we are able to optimize the capital that is tied up in holding the inventory. So there are other classification schemes also available, but in our lectures on materials management, this is one that we are going to cover. There may be others that can be referred to in the related textbooks and the other reference materials available in the libraries. But here we are going to focus our attention on ABC classification of items in inventory management. So by now I think all of you might have been able to understand that what is the need of classification and how ABC classification is done. Now this percentage that we have identified here, this is variable. When you go and refer back to different books, this percentage may be slightly variable, but the broad spectrum or the broad classification will be same. A class will have high value items, but the volume contribution of these items will be less, whereas the C class items, the large amount of volume of items will fall in C category, and the cost associated or the dollar value associated with these type of items will be relatively less. As on your screen you can be seen that it is only 5% of the total value. So now we will try to understand that how to carry out this type of a classification scheme with the help of an example. Now ABC classification, we are going to see an example of ABC classification. Let us see now, there are 10 different parts. So the part numbers are given. Kindly pay attention to the screen that part number 1, 2, 3, 4, 5 and similarly to 10. So there are 10 different parts. Each part is having a unit cost. Like we can say part number 1, the cost is $60. Part number 2, the cost is $350. Part number 3, $30. So in dollars we have, maybe dollar could have been written here, but all these costs or the unit costs are in dollars. So for part 1 the cost is $60, and similarly for part 7 the cost is per unit cost is $10. Similarly we require another information, that what is the annual usage. Now annual usage, we can see that for part number 1 we are using 90 parts or 90 components. For part number 2 we are using 40 components annually. Similarly for part number 6 we are using 180 components annually. So what is the type of information required when we want to do a classification on the basis of ABC? We need to know that what is the unit cost of the part or the component, and what is the annual usage of that component in the industry, and then subsequently we go forward in order to do the calculations and in order to classify these 10 items in A, B and C category. Now we can see we have arranged them in the total value, in the descending order of the total value. On your screen you can see that part number 9, if I refer back to the previous slide, you can see part number 9, the unit cost was $510 and the annual usage for this was 60. So just by multiplying it we get $30,600. Similarly for all the parts we get what is the total value. So we have arranged it in the descending order. So the part number 9 is having a maximum of the total value, that is $30,600, and part number 7 has the minimum of total value. So you can see part number 7, 10 is the unit cost and 170 is the annual usage. So this the multiplying, if multiplying 170 by 10 we get it is 1700. So we can see that in ABC classification part number 7 the total value is 1700, and the overall total value if we sum up all this comes out to be $85,400. Now we will see that how much percentage contribution is done by part number 9 to the total value. The total value is $85,400. So part number 9 is contributing some value. So what is that value? That value is 35.9%. Similarly, part number A is contributing 18.7%. Part number 2 is contributing 16.4%. So similarly, we will get that how much amount is being contributed towards the percentage of total value. That 35.9% is the contribution of part number 9 to the total value. Similarly, we can see from the percentage of total quantity that part number 9 is having 6% of the total quantity, and part number 7 is having 17% of the total quantity. So we can see that what is the total quantity that is being used by the summation of all the annual usage of all the different parts. So in our case we have 10 different parts, and all these 10 different parts we are adding up all these 10 usage of all these 10 different parts to get the total volume, and then we are seeing what is the individual contribution of each part to that total volume. So we have seen that part number 9 is contributing 6%, and part number 6 suppose is contributing 18%, and then we get the percentage of total quantity. Finally we find out the percentage of cumulatives. Now 6 total, part 9 6, then 11, 6 plus 5 11, 11 plus 4 15, 15 plus 9 24, 24 plus 6 30. So similarly we find out the percentage cumulative. This will help us in order to classify the items in A, B and C category. Now here you can see that part number 9, 8 and 2, they are falling under category A. Now how they are falling under category A, that we need to understand. Now we can see what is the percentage of total value, 35.9, 18.7 for B, and part number 2 is contributing 16.4% of the total value. So if we add up all these things, this will come to nearly about 71%. Coming on to part B, 6 plus 5 11 plus 4 15, so it is into the tune of more than 16. So 16% contribution of the total value is being done by part B. So the items that are falling under part B classification are contributing around 15 to 20% to the total value. Similarly, when we see part C, we can see 4 plus 3 7 plus 2 9 plus 2 11. So maybe 11% contribution is being done by to the total value by class C items. So we can see if we do the classification on the basis of percentage of total value, we can see around 70% of the total value is being classified into A category, around 15 to 20% of the total value is being classified into B category, and for around 10% is being classified into C category. Similarly, from the point of view of the percentage of cumulative of the total volume or the percentage of total quantity, we can see that part 1 A category, this is cumulative is 15%. So 71% of the total value and 15% of the total quantity is being classified into category A type of items. Similarly, category B type. So here we can see top 15 have already gone. So we see that another till 40, so 40 minus 15, around 25% of the item are being categorized into B category, and then rest is being categorized into C category. So we will see that what is the percentage contribution towards total value and total volume in the next slide. Now here we can see class A items. So what are class A items? In the previous slide we have seen item number 9, 8 and 2, they contribute, they have total of percentage of total value of 71% and the percentage of total quantity as 15%. Similarly, class B items. Now class B items, which are the total 3 items that are falling in class B category, they are item number 1, 4 and 3. So 1, 4 and 3 can be classified as category B items. So what is their contribution to the total value? That is 16.5, and the percentage of total quantity, they are having 25% of the total quantity, that I have already told when we were discussing the previous slide. Then category C, the percentage of total value contribution is 12.5 and the percentage of total contribution to the total quantity is 60. So the quantity is more here, but the total value or the contribution total value is relatively less, that is 12.5. and which are the items that are falling in category C? As on your screen you can see 6, 5, 10 and 7. So item number 6, 5, 10 and 7 are falling in category C. So we have seen with the help of an example that if we have the information related to the per unit cost of the item and the annual usage of that item, we can very easily classify those items into category A or class A, class B and class C in order to optimize the total cost. So now there is another point that we have seen in the very first diagram of this lecture, that is the economic order quantity. Now we will see what is the economic order quantity. This is the classification which is required in order to minimize the total cost of holding an inventory by classifying the items into A, B and C category. Now we shift our attention to the economic order quantity model. The economic order quantity model, so EOQ, which is called as the optimal order quantity that will minimize the total inventory cost. So basically, as a materials manager or an executive of the materials management department, it is the duty to minimize the total costs associated with the inventory. So EOQ is one of the tools, that is, it gives us the optimal order quantity that will minimize the total inventory cost. If you remember, in the beginning of the lecture we have seen that the total ordering cost reduces when the order size increases and the total holding or the carrying cost increases as the order size increases. So with an increase in the order size, we have seen that the ordering cost is decreasing and the carrying or the holding cost is increasing. So we find out the total cost, and the total cost is minimum for a particular order size. So that order size we call as the economic order quantity. Now we will see what is the basic EOQ model and the production quantity model also we will see, and what is the difference between these two, that we will try to understand. Now there are certain assumptions that are associated with the basic economic order quantity model. First is that the demand is known with certainty and is constant over time. So with the help of a diagram I will explain what does this mean, that the demand is constant. For an example, we can see that the demand is constant means 10 components are used per day or 500 components are used per week. So that means that this demand is going to be constant over a period of time. This is not variable, that on Tuesday we require 15 components and on Wednesday we require 30 components and on any other day of the week we require some other quantity of the component. This is not going to be of that nature. The demand is going to be constant with time. That is the first assumption of the EOQ model. Then we are not considering the shortages here. No shortages are allowed. Lead time for the receipt of orders is constant. It means that the day we place the order and the day we receive the materials, the time in between them is constant. It means lead time is not increasing or decreasing. It is not contracting, not expanding. If it is 10 days, it means it is 10 days and it is assumed as one of the assumptions of economic order quantity. Similarly, the order quantity is received all at once. It means that today we place a order, after 10 days we receive, suppose the lead time is 10 days. So after 10 days when we receive the material, it will be received all at once. Suppose we have ordered 500 components. So after 10 days we will receive all those 500 components in one lot only, means it will not be received in number of lots over a period of time. So this is one of the assumptions which is relaxed for production quantity model. Mind it, please keep it in your mind that this is one of the important assumptions which is relaxed in case of production quantity model, in which we receive the material at a rate. It is not received all at once, it is received over a period of time. Now this is the inventory order cycle on your screen. You can see that this is the order quantity Q that we have ordered. This is the demand rate, this slope. This is the demand rate at which the inventory or the stock of items is being utilized or used. So you can see this is constant over a period of time. It is not variable. It is not changing like this haphazardly. That diagram also we will see. It is not changing haphazardly. It is constant over a period of time. Now this is the daily demand rate. So this is the inventory level. We will see that the inventory level is depleting. Now Q is the order quantity that we have received. Suppose it is 100. Now it is decreasing from 100, and suppose at 20 we have decided that it is going to be the reorder point. So 20 is our reorder point at which we are again going to place an order. Now at this moment of time, this is the point where we have placed the order, and this is the point where we have received the order. So the time between placing an order and receiving an order is called the lead time. So we have seen the last assumption of economic order quantity model, that all the things or all the components or all the order or all the lot is received at once. So as soon as we receive the material here, it is received in a complete lot. Suppose we have Q is equal to suppose 500. So all 500 we have received here. So we will see this will again on the same day, this will again the inventory level will rise to 500, and again we will start using it. So suppose I have taken in the previous example Q as 100, and at 20 we are reordering. Once we received the order, again the Q will become 100, and again we will start reusing it. At 20 again we will place an order. After suppose the lead time, we will receive the order, and all the order will be received at once, and this will again the inventory will again rise, or the level of inventory will again rise, and again it will become 100. So in this way the inventory order cycle will keep on going with time in case of economic order quantity model. Now this is the economic order quantity model. Now C, we can see CO, it is the cost of placing an order. D is the annual demand. CC is the annual per unit carrying cost. Q is the order quantity. As in the previous diagram we have seen that Q is the order quantity whatever we are ordering. So the annual ordering cost is given by CO, that is the cost of placing an order, multiplied by the annual demand divided by the order quantity, and the annual carrying cost is given by the carrying cost multiplied, because this CC is per unit, we can see annual per unit carrying cost. Now per unit carrying cost is multiplied by the total quantity, and it is averaged out and it is divided by 2. So in this we find out what is the total cost. Now total cost, as we have seen in one of the diagrams, again we will see that same diagram with the help of a little bit of animation, that what is the total cost and how it is made up of. The total cost is made up of the ordering cost plus the carrying cost. So ordering cost, this is the ordering cost, and this is the carrying cost. So ordering cost plus carrying cost will made up the total cost, or will make up the total cost. Now the EOQ cost model, we will see how we can derive Q optimum. Now Q optimum we can find out. Total cost, we know that it is the summation of the ordering cost plus the carrying cost. So if we differentiate and put it to 0, we will be able to find out the value of Q optimum. Q optimum will be equal to the square root of 2 times CO multiplied by the annual demand divided by the carrying cost. So we should know ordering cost, we should know carrying cost per unit, we should know what is the annual demand, and very easily we can find out the Q optimum. Then there is another method of finding out the proving the equality of cost at optimal point. This we will see with the help of a diagram, that the total cost is minimum wherever this carrying cost is equal to the ordering cost. So whenever we put that this is the ordering cost on your screen, this is the carrying cost on your screen. So wherever the carrying cost is equal to the ordering cost, we can very easily find out Q optimum. And in order to find out Q optimum, we should know what is the ordering cost, what is the carrying cost, what is the annual demand. If we know all these three parameters, very easily we can find out that what should be the economic order quantity which would minimize the total inventory cost. Now this we will try to understand with the help of a diagram. Now suppose this is the total cost, we will see the total ordering cost will decrease as the order quantity will increase. Similarly, the carrying cost will increase with an increase in the order quantity. So we can see ordering cost is decreasing with the order quantity increase, and the carrying cost is increasing when the order quantity is increasing. So we can see that summation of the carrying cost plus the ordering cost will give us the total cost. So the total cost is this curve which is shown here. So the total cost curve is having a local minima which is going to give us the economic order quantity, and this will pass through this point where the carrying cost is equal to the ordering cost. Now we will have an example of EOQ. We have seen that what is ordering cost, what is carrying cost. Now suppose we want to find out the economic order quantity, what is going to be the order size. For that we require basically three important input parameters, that is the carrying cost per unit, the ordering cost, as well as the annual demand. So let us do an example in order to have a better understanding of the economic order quantity. Now here we see this is carrying cost, this is given as $0.75 per yard. The ordering cost is $150. The annual demand D is given by 10,000 yards. So we can very easily find out the Q optimum, this using the same formula that we have derived. So Q optimum we can find out 2 multiplied by 150 multiplied by 10,000 divided by the carrying cost which is 0.75. So we find out that the Q optimum is 2000 yards. So we should order 2000 yards in one order if we want to optimize the total cost or to minimize the total cost. So the total cost minimum for this Q equal to 2000 is given by this expression, the summation of the ordering cost and the carrying cost for 2000 yards. So we see Q is 2000 here, again Q here we have used as 2000, and the total cost that is giving us the minimum is $1,500. So total minimum cost or the total cost of holding an inventory is $1,500. So how many times we need to place an order, that also we can very easily find out. Now optimum order size is or the optimum order quantity is 2000. So orders per year, because we require 10,000 yards per year, so 10,000 divided by 2000, we find out that we have to place orders 5 times in a year. Now order cycle time also we want to find out, that when we should place an order. Now if 365 days are considered in one particular year, 5 times we have to place an order. So we can say every 73 days we have to have an order in order to have annual or in order to meet an annual demand of 10,000 yards. So with this simple example we have been able to find out that if we require 10,000 yards and we know what is the ordering cost, what is the carrying cost, we can very easily find out that what should be the optimal order quantity. Now we come on to another EOQ model or the inventory management model, that is the production quantity model. So I will just read it for you. An inventory system in which an order is received gradually as inventory is simultaneously being depleted. So in first case we have seen that the order is received all at once, but in this case the order is not received all at once, it is received in stages, or with passage of time we will keep on receiving the order, or we can say it is non-instantaneous receipt model. So the receipt of the materials or the lot or the components will not be at once, it will be over a period of time. This we will be able to understand with the help of an example. So the assumption that Q is received all at once is relaxed. Now P is the daily rate at which an order is received over the time, that is the production rate. This I will explain with the help of an diagram. D is the daily rate at which inventory is demanded. So here also we are assuming that the inventory is demanded at a constant rate. So the demand rate is constant, and a production rate is there at which we are receiving the material. So the material is not received all at once, but over a period of time. Now here we can see this is the inventory level. Suppose this is the total inventory level. So here this is the rate at which we are receiving the order. In previous case it was a straight line like this, but here we are receiving the order like this, and this is the rate at which we are using. Again we are receiving, again we are using. So we are in this in between this time we are receiving also and we are using also. So the rate at which this curve is increasing represents a difference between which the difference between the rate at which we are using the equipment or the item or the inventory and the rate at which it is being added. So this can be very easily explained with the help of a water tank. So in a water tank, suppose we are adding water from one side and we are taking out water from the other side. So water is coming from one side and it is taken out from one side. So if the rate at which the water is coming is more from the rate at which the water is going out, then there will always be an increase in the level of water in the tank. But if the rate at which the water is coming and the rate at which the water is going is nearly same, then there will be no addition in water. So here in this production quantity model, we are assuming that the rate P at which the components are being added to the inventory is much more as compared to the rate at which the items are demanded by the process. Therefore, the difference in between the production rate and the demand rate will keep on adding in the inventory. So the inventory is being added during the production run. So the inventory is demanded also, it is added also. So the maximum inventory level will be this much, and average inventory will be somewhere here, and it will be given by Q by 2 multiplied by in bracket 1 minus D by P. Now D is the demand rate and P is the production rate. So the maximum inventory level is given by Q, that is the order quantity, multiplied by 1 minus D by P, D divided by P, where D is again the demand rate and P is the production rate. Now we can see that this is the point where we have started to receive the order, and this is the point of time where we have received the complete order. So here we are receiving the order over a period of time, and the instantaneous receipt of order, the assumption of instantaneous receipt of order is relaxed in the production quantity model. Now we can see that in production quantity model, again we can find out that what is going to be the Q optimum. The expression is given here. So in order to find a Q optimum, in this case we need three different types of quantity. That is, we need the ordering quantity or the ordering rate or CO, we require the carrying cost, we require annual demand, also we require what is going to be the demand rate, we also want what is going to be the production rate. So we want, in order to find out Q optimum, we require the ordering cost, the carrying cost, the annual demand, the demand rate at which the inventory is required by the factory or the shop, and the production rate at which the material is being supplied by the supplier or the vendor. So production rate, demand rate, ordering cost, carrying cost and annual demand is required in order to find out the Q optimum. Similarly, the total cost will also change. It will be the summation of the ordering cost plus the summation of the carrying cost. We can take an example of production quantity model. Now suppose this is the input that is available with us. This is similar to the example that we have taken, but here this is being solved using the production quantity model. So CC is the carrying cost, 0.75 per yard, dollars per yard, sorry. Ordering cost is $150, same as the previous example. Demand rate is 10,000 yards. The D, that is the demand rate that is required in production quantity model. This is 10,000 divided by 311. Now 311 is a figure which you may not be able to understand. 311 we are assuming as the number of days for which the factory is working. So per day we require 32.2 yards. Similarly, the production rate, so whenever we will place an order, we will receive the order at to the tune of 150 yards per day. So all the order we are not going to receive all at once. It will be received over a period of time at a rate of 150 yards per day. Now again we can find out what can be the optimal quantity for this type of a model and what can be the production run. Now here we can see the optimal Q optimal can be find out. The formula was given. So if we put all the values like the ordering cost, the carrying cost, the demand rate, the production rate and the annual demand, we will be able to find out what is the optimal quantity or economic order quantity. Similarly, we can find the total cost also in this case, and production run we can find out that for how many days we will keep on receiving the order. So 150 when we divide by 2256, which is the Q optimum, we will be able to find out that for how many days the production run will continue. So if we have all these input parameters available with us, we can take advantage of these type of formulations in order to achieve to a quantity which will optimize or which will minimize the total cost of holding an inventory. So also we can find out the number of production runs that would be required to meet the annual demand of 10,000. Now in one particular production run we are having this much 2256, this is the economic order quantity and this will be received. So 10,000 is required, so we require 4.43 runs per year, or we can say 5 runs per year. Similarly, we can find out what will be the maximum inventory level that we will achieve. So that can also be found out, and we can say at any given moment of time the maximum inventory that can be achieved is 1772 yards. So we can see that if we have certain input parameters, we can very easily find out or very easily we can formulate the purchasing doctrine, or we can say we can very easily find out what should be the order quantity that we should order and at what moment of time we should order in order to minimize our total cost. So in these 2 lectures on materials management, we have covered different aspects of materials management. We have seen that what is the scope of materials management, what are the responsibilities of materials management. Then we have seen 2 important models like economic order quantity model and production quantity model, in which we can find out that what is the economic order quantity and when we should place an orders. Also we have seen the ABC classification in order to classify the whole inventory into different classes on the basis of the total value and the total volume. Thank you. Thank you.